We're going to talk a little bit about number systems. First, we're going to talk about the number system we all know the best, which is base 10. So if I write the number 7,436, we know from our elementary math that this is the one spot, this is the tens position, this is the hundreds position, and this is the thousands position. Those are the place values for each of these digits. And we also know we can do this. We can say we have 7,000s. We have 400s. So you should remember this from basic math. We have 3 tens. And we have 6 ones. And we can come back over here and add that up, and we can still get 7,436. And that's base 10, and that's how base 10 works. So we have place values, and we have digits that tell us how many of those values we have to make up the whole number. The next thing we got to ask ourselves is, where do these values come from? Why is it 110, 100, and 1,000? So we're working in the base 10 system. That means there's 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? Each of these place values is determined also because we're in base 10. The ones place is actually 10 to the 0 power. And the tens place is 10 to the first power. The hundreds place is 10 to the second power. And the thousands place is 10 to the third power. Let me write that a little more clearly. 10 to the third power. So that's how our place values are developed for base 10. Let's go look now for the binary number system. So binary is based on ones and zeros. We only have 2 digits, 1 and 0, 0, 1, and we're in base 2. So in base 2, we can determine our place values as well, except this time our base is not 10, our base is 2. So our place values in base 2 would be 2 to the 0 power, 2 to the first power, 2 to the second power, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and 2 to the seventh. We're going to stop there because that is 8 binary digits or bits, right? Each of these place values can hold 1 bit, a 1 or a 0. Okay? So 2 to the 0 power is 1. 2 to the first is 2. 2 to the second is 4. 2 to the third is 8. If you see the pattern here, each one of these is doubling. We're going from 1 to 2 to 4 to 8. This is 16, 32, 64, and 128. So 8 bits make up a byte. So let's put 8 bits in here and convert a binary number to a decimal number. And we're going to do it much the same way we did with that base 10 process a little bit ago. So I'm going to just make up a little binary number here. So here's my binary number, 1001. 1101. Okay. So we have, if we do this just like we did the base 10 project, the base 10 over on this screen, remember we had 7 in the 1,000 spot, so we took 7 times 1,000 equals 7,000, right? Let's go back over here. Now, we don't have to do the multiplication here because we can only have a 1 or 0. So we have a 1 in the 128 spot. So 1 times 128 is 128. So we can kind of skip the multiplying part because we can multiply by 1 in our head. So we have 128. We have no 64s. Right here we have no 60. We have 128. We have no 64s. We have no 32s. We have 1 16 in the 16s position. So let's add that over here. We have 1 in the 8 spot. We have 1 in the 4 spot. We have nothing in the 2 spot. We have a 0. And we have 1 in the 1 spot. So we take all those 1s in their place value, and we add the place values up. 8 plus 6 is 14, and 8 is 22, plus 4 is 26, and 1 is 27. Carry the 2, 4, 5. So this number over here, 1, 0, the number over here, 1, 0, 0, 1, 1, 1, 0, 1, is equal to 157. Okay. So if you need to do this, you need to be able to make this chart from scratch. Okay, 1, 2, 4, 8, 16, 32, 64, 128. Take the 1, double it to get 2, double it again to get 4. You can make it, then you put your binary digits below it. So let's do another one. Let's do that number that I just put there. I'm going to pull out my little eraser tool. And we'll erase this. I'm learning how to use the stylus on this, so probably make a few mistakes here. So let me also erase the first number we did so we don't get confused. All right, so in this case, we have 1 in the 128s column. We have a 1 here in the 64 column. And I gotta remember to switch my pens. We have a 1 in the 16s. So we'll put a 16 over here. And we have a 1 in the 2 column. And if we add up all of the place values, 8 and 4 is 12, and 6 is 18, 19, 20. Carry the 2. 2 and 2 is 4, plus 6 is 10. That's 11. Carry the 1. So this is 210. All right, so that's how we convert from binary to decimal. You know enough now that you should be able to do the binary to decimal conversions on your worksheets.